Hey peeps, welcome back. We are back for another session. Um, Again, we are in chapter 11, and of course, you see on the PowerPoint slide, you see that we're talking about subnets, right? And subnetting and some perspectives of IPv4 addresses. That's actually what the chapter is called in the CCNA 200-301, right? And so this is a very important skill to have. You will be tested on the exam. I can tell you that much. You will be tested on this exam and future exams about subnetting, right? And then how we, how to, plan for networks, create networks, what type of, network you plan for, because you can do anything, right? All these vendors give you the option to do anything and everything, but there's certain things that you have to consider, right? And so, right? So with planning a network, right? You see on the slide, right? You can plan for a network that, you can say, hey, we're going to plan for this subnet, right? To fit so many hosts, right? And just a reminder, right? Hosts are, things on your network are maybe PCs, maybe it's printers, maybe it's PCI devices, like things that take credit cards, right? Maybe mobile scanners, right? A lot of all of these things are hosts, right? On a network, right? Okay. And so you being that network engineer, right? You being that person, right? You have to plan on how big you're going to go ahead and scale your network, because all subnetting is scalability of IP addresses, right? Can you scale up? Can you scale down? Or are you just going to keep the scale the same? Okay. And of course, this slide goes over, right? You can create a subnet size that fits all, right? But maybe it won't. Okay. And that's something you have to think about, right? And so let's look at this, right? Let's look at this diagram. We have, and I'm gonna go ahead and take my pencil out because I like my pencil, right? So we have this subnet, right? Right? It just needs 200 addresses. This is behind the core network. So we're gonna call this HQ, right? This network, right? Right? All three of these networks need 50 IP addresses each. Okay? All right. And of course, we have our connections to our ISPs, right? To our branches, right? From our HQ to our branch, right? They're going to need just two addresses, right? Okay. And so with that, you have to plan, right? What is going to be, how large are you going to make these networks, right? So whenever you're doing a one size subnet fits all, you're going based off your largest need of IP addresses. I'm going to say it again. You're going based off of your largest need of IP addresses. Okay. So in this diagram, my largest need is 200 IP addresses. Okay. And so with that, that means my planning is going to be each subnet, right? I'm not gonna make it smaller for each. Everybody's going to have available to them 200 addresses, even though they don't need it, right? So I'm going to go ahead and make it a slash 24, right? That gives them, as far as usable host addresses, 254 addresses, right? So everybody's going to have, and of course you see it here, right? Let me change it to green. They're going to have 254. We see 254. We see 254, and we see 254, right? That works, right? It can work. You can actually implement it in your network, but you know, is it scalable, right? Are you wasting private IP addresses, right? Um, and you can be, depending on, are you expecting growth? Are you not, right? These are a lot of things, even at the CCNA level, right? Because this is not an entry level cert. You have to understand and know, okay? Because you may be the one that's planning these things or implementing these things, okay? So remember we talked about, we just talked about we're doing a one size fits all, right? But what if we can go ahead and break these things up and make a subnet, right, per broadcast domain, okay? And broadcast domain, and of course, it's a network, right? That is behind a layer 3 interface, and they all can communicate within each other, meaning that if a broadcast message was sent out, all the hosts on that network would be able to hear each other, right? All right. So within networking, there is a concept called variable length subnet mask, or VLSM, right? So you can have multiple subnet sizes with that. Okay. So imagine, let me go ahead and get my pencil, right? Imagine we have a slash 24, right? We're doing a class C, right? We're doing a class C, right? All right. So we use the principles that we used last time, right? And we're going to go ahead and plan off of the largest IP addresses needed, right? We can do that, but we can break it down, right? You can go ahead and break it down, right? And so maybe, right, we'll go ahead and start off. Let's go ahead and say one, sorry guys, my writing is terrible. 192.168.0.0, okay, right? And so this, right, this network right here, let me go ahead and use another color. This network behind HQ, right, behind the core, needs 200 addresses, okay? All right? So if we do our math, right, if I go ahead and get my calculator, right, hopefully you guys can see it, right? Let's go ahead and do the host formula, right? And what is that host formula? It's 2 to the power of x minus 2. And that minus 2, remember we went over it in Lab Fun Day, is minus 2 is, well, let me start off first. 2 to the power of x is telling us how many host bits, right? How many host bits we're going from right to left, right? Because the host bits start on the right of a subnet mask. How many host bits are we going to use for a subnet, right? And with the end result, right, minus 2 is going to give us the available usable IP addresses for each subnet, okay, based on that value, okay? All right, so if we do 2, right, to the power, oops, let me go ahead and clear that out, 2 to the power, oh, not 0, 2 to the power of 1, right, I get 2, right? If I go 2 to the power of 2, I get 4, right? Like where this is going, right? So the 2 to the power of 2, right? We saw that that actually matched up with, let's get a different color, right? Matched up with that, right? That matched up with the IP addresses that are needed between the core and the branches, right? B1, B2, and B3, right? So excellent, right? So we're going to just need, right, 2 IP addresses for them, right? So that would be, of course, right? And let's go back because we're going to do this a little bit slow. Let me make sure I take my time. So 2, right, to the power, right, 2 to the power of 1. We have 2, right? We have 2 usable IP addresses, okay? But with one of the rules of subnetting, right? That would mean we would only have, if we looked at our subnetting calculator, right? Our binary calculator, this would mean we would go ahead and have 2 host bits, right? And that 2 host bits means, right, we would be able to allocate, IP addresses, right, for one side and the other, right? So it would be a slash 30, okay? It'll be a slash 30, okay? Right, in a CIDR notation, okay? So this, let me go ahead and get my pencil. Go ahead and put this down real quick. So, give me 1 second. There we go. So for this would be a slash 30, right? And within a slash 30, you can only assign 2 IP addresses. Slash 31, you can do the same, but it's kind of wonky one would be the network one would be the broadcast address. So they often recommend just doing a /30, right? And so they in the subnet mask, there would be 2 zeros, right? 2 zeros left in the subnet mask, from right going left, right? And that means the last number that has a 1, right, would determine your side of notation, right? So all the ones would add up to 30, right? Coming from left to right within a subnet mask. So we just need 2 for the middle, /30, okay? Let's go ahead now and let's do the math for the 200, right? The 200 need, right? So if we go ahead and we do the host formula, right? So we did 2 to the power of 2. We got 4. That's not enough. We need a little bit more. Let's do, all right, and 2 to the power of 2. Second, 2 to the power of 2, all right, equals 4 minus 2. Okay, that's giving us 2 usable IP addresses, right? That's not enough, right? That is absolutely not enough. So we're going to go ahead, and that's exactly what I showed you guys. That's that /30. Okay, so what we're going to need, we're going to need a little bit more. So let's scale it up a little bit. Okay, let's do 2 to the power of 5, right? Okay, 32 minus 2, right? We're doing the host formula. It's giving us 30 IP addresses. That's still not going to be enough. Okay, let's go ahead and scale it up a little bit more. Let's do 2 to the power of 7, right? 128 minus 2 for the network and broadcast address. All right, that's 126. We're getting close, but we need a little bit more. Okay, so let's do 2 to the power of 8. Okay, all right, that looks better. All right, 256 minus 2, we have 254. Okay, and as you guys can see, that actually matches up what we see on the screen, right? So we can give this, right? And if we're talking about 254, right? And remember how we got there is we did 2 to the power of 8, right? So that's 8 host bits, okay? Right? So from right to left, right, where we have zeros from right to left, right? So we have 8 host bits that add up to 0. So that means if we count the subnet bits from left to right, that means that side of notation for this, right, is going to be, let's go ahead and pull out my handy dandy marker, right? This is going to be a /24, all right? All right, within, and I'm going to rewrite this one. This is going to be a /30, all right? We're going to be safe. There we go. Now let's go ahead and plan for these, right? Let's do the same thing. We're going to do the same calculation, right? So we did a few things, right? Let's go ahead and see if we can find that middle point. So 2, and again, while you guys are learning, start small. Start at the beginning, right? And then move up. So 2 to the power, right, of 4, right? We got 16. That's not enough, right? We need 50, okay? Let's go ahead and scale that up a little bit. So 2 to the power of 5, right? Minus 2, 30. Still not enough, right? Let's do it again, right? 2 to the power of 6. Uh-oh. There we go. 2 to the power of 6, right? 64, right? Right? But we need to go ahead and finish the formula, right? And so minus 2 would be 62. And you guys can see right here, right? That matches up. That is our biggest number, right? That is our biggest number that we can go ahead and assign at least. We could assign to these different broadcast domains that is able to handle the accommodation of 50 usable IP addresses. Okay, and so if we go ahead and we do that again, if I go ahead and look at that, right? So that was 2 to the power of 6, right? So that means it was 6 host bits, right? So 6 zeros from right to left, right? So if we do that, that means, well, how much do we have left? We have 2 host bits left within the subnet mask. So that means that CIDR notation would be, right? It is going to be a slash 26. Okay, right? So if we count from left all the way to right, right? Left to right, we have 26. We have 26 in binary, right? As far as the subnet mask, we have 26 subnet bits, right? 26 ones, right? Bits that are on, right? And for the rest, right, we have 6 bits, right, that are off, right? Host bits that are off, right? Those zeros, okay? So that'll be a slash 26, okay? And so how do we go ahead and do this for a network, right? Right? How do we do this for a network? So if we go ahead, let's say the network is a 192, we're still gonna stick with class C, 192, 168, right? Right? 0.0, right? No CIDR notation just yet, right? Right? For this one, right? For this one at the core, we'll go ahead and give it a 1.0/24, right? Perfect, right? It's 254, right? What can we do for this one, though, right? We can do, right, still 192.168. We can keep it simple. We can say, we can do a 1, right? .2, right? We can do .0, right? But the great thing, right, about variable length subnet mask, right, is that we don't have to waste it, right? We can go ahead and continue with it, right? Because we can go ahead and say, we're not using everything in that subnet. So we can actually say, all right, 2, and forgive me if I don't hit it right on the money, right? But we can go ahead and say 2 dot, right? Let's make sure I have this correct. I'm gonna check my math here, guys. It's been a while, right? If we can go ahead, right? Go ahead and do 192.168, right? And we do 2.0, okay, right? And so that next subnet, right? It starts at 192.168, right? .2, right? Because that broadcast address for the WAN network, right? That broadcast is going to be a .2.3, right? And the next network available is going to be 192.168.2.4, right? And so we can go ahead and split it up like that, right? So if we do, right, we can go ahead, right? If we go ahead and restart this, right? We say, hey, what if we made it slash 26, right? So we do it, right? We won't be able, right? We won't be able to go ahead and start right there, but we can go ahead and start at the next available, right? And it'll be 64, right? That'll be the network address, right? But we can still stay, right? In the slash 30, right? Okay. Now, of course, we're going to miss out on a few, right? But we have expansion, right? We have expansion for more, right? As far as for the slash 30 address in the middle. So you can manipulate it as much as you want. Okay. You can manipulate it as much as you want. It is possible. Okay. All right. So let's go ahead and erase all this. And we're going to keep doing these equations, these maths for the host and what have you. And I want you guys to actually get it, to understand it, and know it's second nature. Okay. And this is an example, right, of what I just showed you guys, right? We can do a slash 30, right? We can do a slash 30 that matches up for all, right? So we have our right? If we go ahead and take my pencil out, right? So we have our 10.1, okay? That's the common, right? We have our 10.1.1.0/24, right? Because the network, right, we're working with is 10.0.0.0.0.0, okay? So we got to work with it a little bit, okay? So if we're using, right, variable length subnet mask, it does two things, right? It can be the subnet mask for all subnets. It can be the subnet for it can be the subnet mask for one subnet or for all subnets or just more than one subnet, right? And that's the beauty of variable length subnet masks, right? And so if we take a look at it, you go ahead and take a look at it. We do a behind the Albuquerque router, right? We have a 10.1.1.0/24. Perfect, right? Perfect, right? So what's our next step up, right? Our next step, right, is we have to assign some networks to the Yosemite, right, behind them, right? So we have 10.2, right? We have 10.2.1.0, right? Went ahead and did that. They have /24s, right? We split it up perfectly fine. Excellent. Excellent, right? We did the same thing over here, right? So this subnet mask, the /24, right? We're using it at behind each router, right? Yosemite, Albuquerque, and Seville, right? Just use one mask, right? But we can go ahead and split it up as well, right? Because you see 10.1.1.0/24, there's no continuation, right? So we have room for more, right? So we went ahead and used it on our WAN. So we have a 10.1.4.0/30 for the connection between Yosemite and Albuquerque, right? But right? We still have some left within the 10.1, right? So we can go ahead and went ahead and assign a 10.1.6.0, right? And maybe between that 10.1.5, something can be used for something else. But we have room. We absolutely have room. Okay? We absolutely have room. So with that, right? With that, this is the power of variable length subnet mask, right? It answers the question of, is there a subnet mask for just one, for one subnet, for all subnets, right? Or more than one. Variable length subnet mask enables us to do so. Okay. Now tomorrow we're gonna go ahead and do a lab, right? I want to do some more math practice, right? We went over the host formula. We now need to go ahead and take some time to do the subnet formula. Okay. What I want you to think about here is whenever we went ahead and made the binary system graph, right? We made that table, I'm sorry. We made the binary system table, right? A subnet mask, right? The host portion, right, starts all the way to the far right, right? And then goes up, right? The subnet version, right? And I'll go back to the diagram, right? The subnet version is, as far as from the subnet mask standpoint, starts all the way to the left, okay? So we need to go ahead and just make sure that we fully understand it. So we're going to do a couple more exercises. We're going to have lab fun day tomorrow. I know it's going to be a lot of math, but I think you guys are going to have fun. All right. Thank you guys for joining in, and I will see you guys tomorrow.